Okay, in this video we're going to be delving deeper into the unit circle. We were introduced to the unit circle in the previous section. And remember, in the previous section we just focused on the intercepts that the unit circle made with the x and y intercepts. And so what this first paragraph is saying is, recall that when the angle is not a multiple of 90 degrees, the cosine and the sine is going to be inside one of the four quadrants. Because when it is a multiple of 90, that's when it's on one of the axes. But it's between 0 and 90, it's going to be inside of one of these four coordinates. The quadrants. The quadrants enable you to quickly determine if the cosine of the angle and the sine of the angle are either going to be positive or negative. Relationships that are true for all values of variables in a domain are called identities. The basic one relating sine and cosine is called the Pythagorean identity. So this is what you want to make sure you know for the first part of these notes, is the Pythagorean identity. The Pythagorean identity is defined as this. It's the square of the cosine of an angle. Whoops. Plus the square of the sine of an angle is always going to equal 1. Because if you think about it, a squared plus b squared equals c squared. Well, when we were talking about the unit circle and we started out, remember the hypotenuse is always going to be 1 because this is a unit circle. So the radius of the circle is always going to be 1. So the cosine squared, the x squared plus the y squared, the sine squared, is always going to equal 1. Let's look at an example. It says approximate the coordinates of point C to the nearest thousandth. You want to make sure you know that the thousandth would be 3 numbers after the decimal. So we want to estimate the coordinates of point C. This is what we did in the previous section. So you want to remember that it's going to be the cosine of the angle is your value for x. The sine of your angle is your value for y. So to find the x value, I take the cosine of 28 degrees. Well, the cosine of 28 degrees is 0.883. I take the sine of 28 degrees. Well, that gives me 0.469. So that would be my values for the x and y. And we want to verify that your coordinates in part A satisfy the Pythagorean identity. So what you're going to do is you're going to take your value for x, 0.883, and square it, plus your value for y, 0.469, and square it. We want to see, does that equal 1? And sure enough, if you do that on your calculator, it does equal 1. So it is a true statement. So this does verify, it does satisfy the Pythagorean identity. Why don't you guys try the next one? Why don't you try this? So hit pause and press play when you're ready to check your answer. Okay, so what you should have done is this. You should have taken the cosine of 52 degrees and the sine of 52 degrees. And when you do that, you should have gotten as your answer the coordinate 0.616 and 0.788. So to verify that they satisfy the Pythagorean identity, you'd take 0.616, square it, take 0.788, square that, and sure enough, you get 1 as your answer. So in the previous video, we talked about the 0, the 90, the 180, the 270 degrees. And we talked about the values of each of those degrees, the sine and the cosine of those at those points. But today we're going to be looking at more parts of the unit circle. And you want to be familiar with these 3 angles in quadrant 1, the 30 degree, 45 degree, and 60 degree angle. These are the exact values. So the cosine of 30 degrees is square root of 3 over 2. The sine of 30 degrees would be 1/2. The 45 degree angle is really easy to remember. It's square root of 2 over 2 for both the cosine and the sine of 45 degrees. Where the cosine is 60, that's 1/2, and the sine of 60 is square root of 3 over 2. So you want to memorize those, and we're going to talk about how these 3 quadrants relate to quadrant 1. Now quadrant 1, that's where both the x and y are positive. Okay, that's important to remember. In quadrant 2, remember that's where the x's are negative, but the y's are still positive. Because if you graph any point over here, this would be, for example, the point negative some number for x and a positive value for y. In quadrant 3, that's where both x and y are negative. In quadrant 4, that's where my x's are positive, but my y's are negative. Now that's important because each of these quadrants are all reflections in some way of the coordinates in quadrant 1. Okay, so now this next part, I'm going to start filling in parts of this unit circle, and you'll see how it's all related here in a minute. But basically what's going to happen is, in order for us to see what or how each of these quadrants relate to quadrant 1, we're going to have to know how to do something with these angles. So, for example, if I have an angle that's between 90 and 180, and I want to figure out how it relates to an angle in quadrant 1, what I'm going to do is this. I'm going to take 180 degrees minus the measure of the angle, because then that'll give me the angle, like I said, that it corresponds to in the first quadrant. If I have an angle in quadrant 3, so it's between 180 and 270 degrees. If that's the case, I'm going to take the measure of the angle and then subtract it from 180, because in this case, it's more than 180 degrees. So to figure out how many more degrees from 180 it would be, I would subtract it, or subtract 180 degrees from it, and that'll tell me the how much over 100 degrees it is, which corresponds to the angle in quadrant 1. And lastly, if we have an angle in quadrant 4, we would take 360 degrees minus the measure of the angle. So let's look at some examples. So we're going to work on these examples here. We want to find these exact values. These are all angles that correspond somehow to one of these angles in quadrant 1. So here's how you approach this. Start out by we're looking at the sine of 210 degrees. You want to first figure out what quadrant is that in. Well, it's more than 180 and less than 270, so this is in quadrant 3. And in quadrant 3, the sine of an angle is going to be negative. Because remember, the sine of an angle is your value for y. Because remember, we're dealing with our unit circle. The x value is referring to the cosine of the angle. The y value is referring to the sine of the angle. So the sine of 210 degrees is in quadrant 3. I know that it's going to be a negative number. So now what I do is I figure out, well, how does it relate to an angle in quadrant 1? Well, I know it's more than 180 degrees, so to figure out how much more, I take 180 minus, 210 minus 180. And that gives me that it's more than 30 degrees past 180 degrees. So that relates to a 30 degree angle in quadrant 1. Well, in quadrant 1, the sine of 30 degrees is 1/2. So remember, this is going to be negative. So your answer would be a negative 1/2. What if it was the cosine of 210 degrees? Well, again, the cosine of 210 degrees is going to be negative. And it's the same angle, so it's also going to be related to a 30 degree angle in quadrant 1. Well, a 30 degree angle has a cosine of square root of 3 over 2. So this is going to be the opposite of that, so it's going to be a negative square root of 3 over 2. Let's try another one. 150 degrees. 150 degrees is in quadrant 2. Quadrant 2, that's less than 180 degrees, so I'm going to take 180 minus that angle to figure out how it relates to an angle in quadrant 1. 180 minus 150 is 30. So this relates to a 30 degree angle. So I look over here. Well, first, before I even do that, we want to remember to look to see if it's going to be positive or negative. Sine of an angle in quadrant 2 is going to be positive, so it's going to be a positive answer. Look over here, find my 30 degree angle, because again, 180 minus 150 gives me 30 degrees again. So it corresponds to the 30 degree angle, and the sine of 30 is 1/2, so this would be a positive 1/2. So the next one, the cosine of 135 degrees. Well, 135 degrees, that's also in quadrant 2. But the cosine of an angle in quadrant 2 is going to be negative, because the x value is always negative in quadrant 2. So I know my answer is going to be negative. So now we need to figure out, well, how does it correspond? What angle does it relate to in quadrant 1? Well, so I take 180 minus 135. When you do that, you get 45 degrees. So this corresponds to a 45-degree angle, which is always square root of 2 over 2, whether it's cosine or the sine. So your answer would be a negative square root of 2 over 2. That would be your answer. Let's try the sine of 330 degrees. 330 degrees is in quadrant 4. Quadrant 4, the sine is going to be negative. So this answer, no matter what, is going to be negative. 330 degrees then would be, to figure out what angle it relates to, I would take 360 minus 330, and that gives me 30 degrees. So again, it corresponds to the 30-degree angle. The sine of a 30-degree angle is 1/2, so your answer here would be a negative 1/2. Why don't you guys try the sine of 240 on your own? So why don't you guys take a minute to do that. So if you need to, hit pause and hit play when you're ready to check to see if you got it right. Okay, let's see how you did here. So 240 degrees. You should have first started by asking yourself, what quadrant is that in? What's in quadrant 2? So that means both the sine and the cosine are going to be negative. So this is going to be a negative value. So now we need to figure out how it relates to an angle in quadrant 1. So I'm going to take 240, because this is more than 180, so I'm going to take 240 minus 180. Well, 240 minus 180 is 60, so this relates to a 60-degree angle. And the sine of 60 degrees is square root of 3 over 2, so this is a negative square root of 3 over 2. And that's your answer. So hopefully you're starting to understand how the unit circle comes together. And in your assignment, you'll be looking at more of these types of angles. So we will stop here. So with that, good luck on your assignment.